Hi guys, so today we're going to do some fun stuff with the Arduino. I wish I could be there, but I have a doctor's appointment today. So because it's with the Arduino, of course, what you're going to what you're going to want to do is go to the back of the room in that metal drawer. You open it up and you'll see the green boxes that we've been using. You should get out of that, or in that should be an Arduino with a growth shield on it. There should be some wires. And one of the newer things we're going to do is we're going to use an LCD screen. I'll show you a picture of it in a little bit, but it should be in the box. And of course, don't forget to get one of the USB cables that you'll plug into a USB port on your computer and plug in to your Arduino. Now, we're going to do something a little bit different today with it. We're going to find a library for use with these LCD screens. We're going to install that. And then we're going to run an example program as we've been doing, see what it does, then look at that code and try something new and different. Primarily what you're going to be doing most of today is playing around with what's called pixel art, which should be really easy. So anyway, first step you want to do, you want to open your Arduino IDE. I already have mine here in my start bar. I also have it on my desktop. But if you can't find it in either of those places, as long as you download it, you type in AR, it should come up Arduino IDE. You can run it. So double click that and that'll bring up your Arduino IDE. Give it a minute to do that. Now, of course, the first thing it does is it uploads just a empty sketch. We're going to actually upload an example in a little bit. But the example we want to upload is going to not already be in there. If you recall, let me go back here. If you recall, when you go to File, Examples, you guys have this 1 through 11 and maybe one or two others after that, I don't know. But we're going to download a new library. And often when you download a new library, it'll come up with, see, all of these are different libraries here. They'll come with their own example codes. The one we have, I actually have uninstalled in mine because I'm going to walk you through getting it. So anyway, open up your Arduino IDE. Next, not that, let's go here. Next, what you want to do is open a browser. Chrome is fine. And then under Chrome, I want you to try Seed, SEED, Studio, RGB, Backlight, LCD. So it's a liquid crystal display with a black light that can be red, green, or blue, or some combination thereof. And hit enter. Ideally, you'll come up with this Seed Studio Wiki. That's the one you're after. Don't bother clicking these others. They're not worth your time. This one has everything you need. You'll have that S there, Grove LCD RGB backlight. So click that. This is the device that we're going to be working with today. And again, if there's not one in your little green box, then go back to the drawer and switch around until you find one that has one in it. This is version 2.0. I do have some others in some other boxes that are older, but this is the one you want. Now, the first thing you might notice is, like all the Grove stuff, it's going to use the same wires that we've been using already. Those wires are kind of all four together with a plug at either end. And it's got, I believe it's black, red, white, and yellow wires that plug in here. If we scroll down, and you can just kind of ignore it, pay attention to where I'm scrolling now. Let's scroll down a little bit. Keep scrolling, keep scrolling, keep scrolling. You'll get to this picture right here. And this shows you how this LCD connects to your Grove shield. And you'll notice it's not one of the digital pins that we've been using. And it's not the analog pins we've been using for like when we used a potentiometer or a knob or whatever. It's these I2C ports. Now, you don't need to know a lot about I2C to be able to use it. Basically, it's a protocol that allows you to connect multiple devices together. Each device on the, what they call a bus, has everything that's plugged in the same place as a bus. Each of them has a built-in address, and so when communication is done, it's done by address. All of that is taken care of for you, though, by this thing called a library. Somebody already did a lot of the heavy-duty coding to make using this device very accessible. So all you really need to do is plug one end of the wire into your LCD RGB backlight. The other wire plug into any one of these four I2C inputs at the bottom of your Grove shield. Now, I intentionally came to this picture not simply to show it to you, but to use it as a marker. You're going to come down to this point on this page, which again, you got to by typing Seed Studio RGB Backlight LCD. I know some of you are behind. It always happens. Then click on Grove LCD RGB Backlight, and it takes you to this page. Then scroll down. Do you see this picture that we just talked about? Just below that picture, well, it's still on the screen even, we see step 1 says download the library. So all you're going to do is click on that. And just wait a while and you'll notice your downloads up here in the top right, you've downloaded something. And it is the library. Now it's in a type of file called a zip file. Don't click this. Do not click open. If you already clicked open, just close it, go back, go to your downloads. Or you can go to your downloads this way if you want. And you can see, like by going to your file, your folder browser thing here, go to downloads, it'll be there as well. But you'll notice that this file here has a little zipper on it. It's what they call a zipped file or a compressed file. Another way to get to that, if you wanted to, you can hover over this and click on this guy. It does the exact same thing. It opens that location in your library, your downloads, not in your library, in your documents. Opens your downloads folder, and it shows, right, this is what they call a zip library. In many cases, you'll want to unzip that, but you don't have to for this. So as long as you know where it is in your downloads, you should be okay to move forward. So we've downloaded that, and we've hooked this up properly. So now, let's go back into Arduino IDE, and under Sketch, there's Include Library. So in the Arduino IDE, File, Edit, Sketch, Include Library, okay? And if you go to the top here, the very top, it has Manage Libraries and Add.zip library. This is what we're going to do. We're going to add the .zip library. It's going to come up. It's going to open a browser in your browser. I mean, not browser, a File Explorer. That's what it's called, File Explorer. And you want to find your Downloads folder there. And there it is in your Downloads folder, this .zip Grove LCD RGB Backlight Master, that. Click Open. And down here, you can see it's now processing the zip library. It's installed it. It's successfully installed it. So it's there now, which is great. Because now, if you go to File, and you go to Examples, in addition to having 1 through 11 here, the basic built-in libraries, you should have, not all of these, but this one, Grove LCD RGB Backlight. Okay? So this is the library that works with that device. And we're going to investigate, first of all, we're going to investigate Hello World, which is not a brilliant program, but it's an okay program. So you'll open that. And by the way, if I had you guys do this already, you can run through the video here if you've already installed the library. But if you haven't, now you know how to do it. So it opens up this example. We can close this other IDE that's the basic sketch thing. We don't need it. Okay. Let's make this full screen. Okay. As usual, I recommend you read through this, but a couple things I'll point out. These two commands here, those are new to us. Those actually add in a whole bunch of code that you never even nearly need to look at, called the wire library and the RGB LCD library. So those two lines have to be in any program that's using the I2C interface and any program that's using the RGB LCD with that interface. Then there's another line here that actually establishes that communication and gives the name LCD to your LCD. So every command after these 3 lines that begins with LCD dot is really calling code in this library and this library to communicate to that screen for you. So those 3 lines, pretty important. The next 3 lines are declaring variables, color R, color G, and color B. These are the color brightnesses of the backlight of the LCD. So it's going to be all red, no green, and no blue. This sets up the LCD. You can get LCDs of different configurations, and some of them have more columns and more rows, but that's all it is. It's going to just configure the library to expect to communicate to an LCD that has 16 columns and 2 rows, columns and rows. It's then going to set the color of the backlight to be this much red, this much green, and this much blue. Then it's going to print at the current location of the cursor, which turns out to be the top left. It's going to print these literal things, HELLO, comma, world. It's going to wait a second. Then it's going to move the cursor to the first column on the second row. Now this might be confusing to you because what we've got here is what we call zero indexed locations. What that means is that 0 is the first of the things. So 0 is column 1. This is always column, then row. So 0 is first column. 1 would be second column. 2 would be third column. Now that might seem confusing. Why would 0 be first? Why wouldn't you make 1 first? The answer to that lies into some very fundamental coding stuff involving something called modula or remainder math that we may or may not get into later, but it actually is easier for a lot of coding for the first item in a list or a location or something to actually be at address 0, not address 1. So this is basically saying set the cursor on the LCD, set cursor on the LCD to be at column 0, the first column on the left, and row 1, the second row. See, it started out putting hello world on the first row. This puts the next thing on the second row. And it says LCD print millis divided by 1,000. Well, millis is the number of milliseconds since the program began. So it's basically an internal clock counting along. It does the same thing as your delay commands that we did right here and here. So this delay 1,000 is delay 1,000 millis. So it uses the internal clock, waits till 1,000 millis have clicked off, and then it moves on. This one will just tell you how many millis have elapsed, gives you a number, and then it divides it by 1,000. So basically, between 0 and 1 seconds, this returns a 0. Between 1 and 2 seconds, this gives you a 1. So this should give us 0, 1, 2, 3. And it resets, each time it goes through the loop, it resets to the beginning of the second row, and then it overwrites the number that's already there with a new number, which is how many seconds have elapsed. Again, you don't have to in detail understand all of this. What I would recommend you do now is plug in, make sure you've plugged in your RGB LCD into an I2C port, your Arduino with the Grove Shield on it, attached via the USB to a USB on your computer. You go up here and you'll click the down arrow and select that. Now, I made a mistake. I didn't bring an Arduino home with me. I often do, but I didn't today. So I can't connect one and show this to you, but you've done it several times already. When you click this down arrow, the Arduino that you plugged in should appear, select it. Once it's selected, then you can click this upload button. That will upload the code to your Arduino that is connected like this, and you should see the program execute and do this stuff. Your assignment, let me even bring up this to make sure this is absolutely clear. Your first assignment today is to, 1, change, and my wrist killing me. Upload the example code to make the backlight be some other color. And it doesn't matter to me what other color. Purple is fun, and purple is pretty easy to figure out. Purple might be, all red and all blue. Try that. So if you look at the code, I'm sure you can figure this out. 255 is the maximum and 0 is the minimum. So you're going to put numbers in here, change those numbers, run the code, should make the backlight change. Once you've done that part of the assignment, the next thing you want to do is change and upload the example code so that it says something other than hello world. Okay. I don't care what you put. If you need an advice, I would have it say, I am awesome. Make yourself feel good, because why not? You deserve it. Anyway, that's your first assignment. So do that. When you're done, actually, maybe I should do a 3 on that. When you're done with that, save as my RGB LCD. Just save it. So when you get finished making the changes in your code, and you can figure it out. I think it's pretty easy. You're changing that and you're changing these, and you upload it. Then when you go to File, you click Save As. You don't really know where it's saving, but don't worry about it. It'll always save in the same place, so you can always find it. And instead of calling it Hello World, you'll just call it my RGB LCD. If you want, you can use camel casing on that. It doesn't matter to me. All right, now that you've done that, woo, yay, great, whatever. What I want you to do next this is the second part of your assignment. You're going to go to File, and you're going to Examples, and this time you're going to go to Grove RGB LCD backlight library, and you're going to open something called Custom Character. Okay. Once that's open, you can actually go and close the prior one, the My Hello World, and yours will be saved, but I'm not going to save this one. Okay, so that Hello World closes. Wait, did I close the wrong one? Did it not close? Try again. Don't save. There we go. I don't know why it didn't close right. Anyway, so this is the code you're going to do. Again, like every time, I recommend you read through it. This should be familiar. Here's something completely new. Make some custom characters. Byte, space, heart, bracket, 8, bracket, equals, another kind of bracket, OB, and 1, 2, 3, 4, 5 zeros. And then OB, a comma, and then OB, 1, 2, 3, 4, 5 numbers, either zeros or ones. And it's called heart. It finishes with a bracket and a semicolon. Make some custom characters. Weird. Look through that. You don't have to understand all of it. This is also here under Setup, which runs once. It creates a character that gives a value of 0, and the character is called heart, which is the name exactly of this thing. Okay. And there's also character 1 will be the smiley, character 2 will be the frowny, character 3 is arms down, character 4 is arms up. And there's an if1 and an end if. I'm not sure what that's about, but whatever. It sets the cursor. We know what that does. It prints I, then it does this weird thing, and then Arduino, and then it writes lcd.write1. Notice this is print. That's write, print, and write. Print and write must be different. I think they'd be the same. Then some other stuff down here. It sets the cursor. It writes 3. It delays some time. Then it sets the cursor back to the same place and writes 4 in the delay time. And it comes around again. Oh, it does say sensor reading. Oh, come back up here. Does it say? Oh, it doesn't say. There's an additional bit of wiring you need to do for this. And that additional bit of wiring is that you need to take the knob, the little adjustment, the potentiometer, Grove knob, I think that's what it's called. See if I can find a picture of it. No. Let's do Seed Studio. No, it's not. Let me try potentiometer. Oh, I think I know what it's called. A rotating knob. Is that it? Rotary angle sensor. That's what it's called. It's that guy, which we have a bunch of in the back. They look like that. They look like that. Top and bottom. You're going to take one of those, and you're actually going to plug it in. Probably, let's check. Oh yeah, you're going to plug it here at A0. You're not going to put this guy in. So you're going to have one of your I2Cs is going to go to the LCD, and the other, the A0, is going to go to one of these rotation sensors. So I'd forgotten about that part of the code. Should have told you earlier, probably should have set it up differently. But that's what this bit of code is. It's going to read that knob you have, and it's going to make it, instead of going from 0 to 1023, 200 to 1000. And that's going to change your delay. See how your delay time, so it'll make basically what's happening here over and over again go faster or slower depending on how you have it turned. Anyway, wire it up. Make sure you've selected your proper board. Run it. Look what it does. I think it's fairly self-explanatory. One of the key things, though, is that also in the drawer in the back of the room, that's right, everybody pause for a second, take a deep breath, back to the back of the room, in the drawer where you got your green boxes with your Arduinos in it, there should be a small stack of graph paper. And the graph paper is kind of, sort of, looks like this. It's got a bunch of blue squares on it like this on a piece of graph paper. And I've done something on my screen here that is going to help you understand what custom character does and allow me to make the assignment. So, this is getting long. Okay, so let me move on. So if you look at custom character, and we go down to, let's see, here, it does an LCD write 0. Now don't worry about what this unsigned character thing is here. That's a little bit confusing. But what it does is LCD.write. After I space, it draws a heart on that LCD screen. Okay, heart, character 0, character 0. Yes? So let's take a look at what heart is. Go back up here. We see that heart has a row of 5 zeros, then a row of 0, 1, 0, 1, then a row of all ones, 0, 1, 1, 1, 0, 0, 0, 1, 0. I think this might make sense. If you kind of squint your eyes a little bit, you might be able to see a heart there. But to make it easier for you, I made the paper for you there. And so if you take that paper and you say, all right, let's not put anything on the first row. The first row, B of heart, B is all zeros. So 0 means nothing. Okay. The second one, let's ignore the 0 B at the beginning. 1, 2, 3, 4, 5. The second and fourth one have a 1 in there. So if I go to here and I take the second one and I color it in, and I take the fourth one and I color it in, okay, that's the 0, B, the line 1 is all zeros. The second line is 0, 1, 0, 1, 0. The next two lines are all ones. The next line, our next three lines are all ones. So let me just make all these like this. I think this is pretty self-explanatory, but I'm going to go ahead and do it for you. The next line after those three, so let's look at this again. It goes all zeros, 0, 1, 0, 1, 0, ones, 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 0, 1, 1, 1. So this is 0, 1, 1, 1. And then the last line, magically a picture appears, or the last two lines, this one has a 1 in the middle and the next one's all zeros. So let's take the next one, let's put a 1 in the middle and leave all the rest as zeros. Oops, not there, here. And we see there's a heart. So you can take your graph paper and you can literally color in and you can make any picture you want by doing this pixel art is all this is. It's just pixel art. There's nothing magic about it. Once you take a look at it, most of you will have gotten this already, but if you haven't, I'm just giving you extra support here. So let's look at this one, smiley. All zeros, a 0, 1, 0, 1. So let me go here. All zeros, a 0, 1, 0, oops, 0, oops, not there. Back up. That one is not a 0. 1, 0, 1, 0, 1, 0. Okay, that's the third line of smiley. And we come down 2 more rows of zeros, then a 1, 0, 0, 1. So 2 more lines of all zeros, then a 1, 0, 0, 0, 1, like that. And then the next line, come down here, is 3 ones in a row. In the middle, 1, 1, 1. And then the last line's all zeros. There's your smiley, right? So what I'd like you to do is get a piece of that paper, put your name on it somewhere, make the smiley, make the heart, make the smiley, make the frowny, make the arms down, make the arms up. Okay? So heart, smiley, frowny, arms down, arms up. Just draw them on the paper with your name on it. Then, here's your assignment, your actual assignment here. Okay? Second assignment. Mark graph paper with heart, smiley, frowny, arms up. Oh, sorry, this is stupid. Arms down. Put your name on it. Okay. Then 2, make your own pixel art. Okay. So you're going to get your paper and you're going to go in there. Oops. You're going to get your paper and you're going to go on that piece of paper, not this thing, and you're going to make your own stuff. I don't care what it is. It could be do something maybe that's like I make a budding flower like this. And by the way, for this stupid thing I made here, I don't actually have to do a 1 in here, but you do have to do 1s in the Arduino. So oops, I don't want to keep hitting there. And it could be anything. You're just making pixel art. If you want to get inspired by going online and ask for 5x8 pixel art. By the way, you might notice this is a 5x8 thing. It doesn't look that much like a flower bud to me. Let me make that back to a 1. Let me make this a 1. Let me make this a 1. Make this a 1. Okay, so there's the unopened flower, and then you could do maybe an open flower, right? I'm just making this up as I'm talking to you right now. I do remember somebody did it one year, several years ago. Somebody did something similar to this, and I thought it was kind of cute, so I'm just duplicating. So I guess I better do this. Kind of boring right now, I know. You can fast forward through these videos, by the way, which if you're not already doing, I'm surprised. So I have a unopened flower and an open flower, right? It kind of opened up. So what's kind of cool about that is if you look at the code, in this portion down here, they have the arms up and then the arms down, the right 3, and the arms up is right 4. So if you go in here and you change arms down to, and this to bud and bloom, and you redo the numbers in here. Now you'll have to redo all these numbers. I'm going to do that right now. I've used enough of yours. You could change this to bud and this to bloom, and now when you run this program, instead of him doing his arms up and down, quicker or slower, depending on how far you've turned the knob, it'll be the flower opening and closing and opening and closing and opening and closing. You can do anything you want. I just want you to have fun with it. So your second part of your assignment is make your own pixel art on the graph paper, but then transfer it to the code. Then run and play around with your code. Goodness. Until you think you have something cool / interesting to share with me. And then the fourth thing you want to do is save your work as my custom character. That's all I really want you to do today. So have fun with that. Get the graph paper out. Oops, where'd the graph paper go? Get your graph paper out. Draw these things out. Do draw them out, please. I want the paper showing you recorded the smiley and the frowny and the heart and the arms up and arms down, and then your ideas, and you can do a bunch of them. You take extra pieces of paper, it doesn't matter to me, but come up with some things you want to draw. Somebody did a little dragon the other day. Somebody made a smaller person that could jump up and down in the space. You can do all kinds of stuff with it. Bows and arrows, I don't care. Get inspired, use AI. It really doesn't matter to me. My goal is for you to figure out how to make your own custom characters with their own names like Bud and Bloom. One thing I would suggest, one last thing before I go, instead of using 0 for whatever this first one is, make it number 5, and that way when you decide to call it, you don't have to do this unsigned char thing. You can just go 5 instead of 0. So anytime you see unsigned char 0, just go here when you're creating the characters and change that 0 to a 5, and every place else you want to use that, instead of LCD.write unsigned char 0, just make it 5. It's going to be so much easier. I don't know why they chose to make the first one 0. It is what it is. See if you can maybe move it around by setting your cursor in different locations. Perhaps you can make something move left to right as you go through the circles through here. Don't be afraid to make up your own variables up here. So you can make up a variable like int call equals 0, and then you could have the where it sets the cursor, you could have it be call and call like that. And then at the end of each line, maybe you should go call is equal to call plus like that. So it changes which column it's in. It starts to the left and moves to the right over time. If you don't like that, oh, by the way, some of you might know some code that looks like this. If you don't worry about it. That's the same thing. It's called an incrementer. You just do, in fact, oh yeah, sorry, this is the incrementer, like that. This line is exactly the same, if you want to use this, as call equals call plus 1. That's the same line. So if you want to do this, where you make it move left to right, you can do that. Some of you may want to, add in an if statement so that it bounces back and forth between the two. So instead of incrementing, you could add a number, and the number goes from being negative to positive when the column gets bigger than 15 or smaller than 1. All kinds of stuff you can play with. Be creative. Have fun. This video has been way too long. Have a wonderful day. I will check your work on Wednesday. Also, check your email. There were a couple of people who had some work that was outstanding that I need to, or by outstanding I mean not turned in yet. I do need to it's mostly on completion. Just grade it so that I have grades in the grade book for you, because I think grades are due right after the break. And I'll see you on Wednesday. Thank you, guys.